Hi guys, this is Mrs. Berg again. We are going to be talking about 11.8 today. This is volume of a rectangular prism. There is basically two different formulas for volume, and you're really going to learn this next year. So I'm just going to show you both, but in this case, I want you to know a volume of a rectangular prism. So I'm going to flip this around and we're going to start talking about this. All right, with volume of a rectangular prism, you could always see it as length times width times height, or volume is also known as what I call big B times H method. Now, why is this important? It's because this is the one that you're really going to be using next year, because you're what the big B is, and I'm going to write that over here, and you guys can write this along with me. Big B means the area of the base, or in other words, the bottom shape. So in this case, on a rectangular prism, the bottom shape is either going to be a rectangle or a square. So in this case, with rectangular prisms only, you are going to have either a square or a rectangle. Now, next year, you're going to see other things, and that is why big B times H works for everything, because sometimes you're going to have like a pyramid, you're going to have lots of different ones. You're going to have a cylinder that you're going to find the area of the volume of it, and as well as other shapes. So this is the one that they generally use up in the middle school, because this is universal. But for this one, because only fifth grade is going to be doing it with rectangular prisms and stuff like this. So since it's just rectangular prisms this year, ours is going to be length times width times height. But also you could look at it this way as well. What is the bottom shape? The bottom shape in this case is a rectangle. So you could also do the width times the length, or the length times the width, doesn't really matter. So in this case, our bottom shape is length times width, and then times height. So that's why both of these work this year. So I just want you to know that there is two different ones to know about. Now, let's look at this bottom one here. Actually, generally speaking, they always say the length is this way and the width is back, but it doesn't really matter. So this way, what you're supposed to do is figure out how much is going across. So if you look, there is 1, 2, 3. So this one is 3. And then the width is 1, 2, 3, and 4. This one is 4. So to do this, I would do 3 times 4. What is 3 times 4? That is 12. And then it's square units because it's only the bottom shape. This is like unit, and then this one is units. So units times units is units to the second power, or squared units, because we haven't put in that height yet. So they're just talking about the area of that bottom shape only for now. And then when you turn it to 3D, that's where the height comes into play. All right, next, it says Jan built a rectangular prism, showing at the right using 1-inch cubes. The prism has a base that is a rectangle and a height that is 4 cubes. What is the volume of the rectangular prism that Jan built? You can find the volume of a rectangular prism by multiplying the number of square units at the base shape or bottom shape by the number of layers of its height. So each layer on Jan's rectangular prism is composed of how many inch cubes? So if you look here, this would be your length times your width. Well, if you look here, it would be 1, 2, 3, 4, and then times how many are going this way? There is 1, 2, 3. So this would be 4 times 3. So what is 4 times 3? That is 12. Now, it's very hard to see this bottom. So if you think it's easier to see this top, that could help you as well. So again, this is 4 by 3. So 4 times 3 is 12 inches cubed for one layer. Now it's saying, here is the height. So if you have just one layer, it is 12 cubic inches. If there are 2 layers, that means 12 plus 12, that would be 24. If there were 3 layers, that would be something. And then 4 times something is going to give you this. So if you could see some type of a pattern here, what should you do to 1 to get it to 12? What should you do to 2 to get it to 24? If you look, the pattern is multiplying by 12. So therefore you take the layers, the height of the layers, and you times it by 12 to get your volume. So I'm going to multiply the height by 12 to get my volume. So here, to figure this out, I would do 12 times 3, which is 36. And then I would have to do 4 times 12, which is 48. So in this case, how does the volume change as each layer is added? So as each layer is added, how much is being added to it? Well, each layer has 12. So as you keep adding on a layer, it would be just 12 more cubes that are being added to the volume. So that is what you're going to be writing. Each layer adds on 12 cubes to the volume. All right, now what does the number you multiply the height by represent? So what does the number you multiply the height by represent? So they're saying height times what is what it's saying. Well, remember, if you look up here, we talked about what that is. That is your big B. So what is the B stand for? Big B stands for area of the bottom shape. Or the number of cubes in one layer. All right, so it says, so what is the volume of Jan's rectangular prism is blank inches cubed. So remember it said that he's going to have a height of 4. So therefore, if that is we would do big B times H. Or remember the big B, the bottom shape, has 12 in each one. And then the height is 12 cubes high. So you would have to do this. So 12 times 4 is 48 inches cubed. Okay, next. All right, next one. It says relate height to volume. Tony stacked cube-shaped beads that measured 1 centimeter on each edge of the storage box. The box can hold 6 layers of 24 beads with no gaps or overlaps. what is the volume of Tony's storage box? So it says, what are the dimensions of the base of that box? So again, it said that the box can hold 6 layers of 24 beads. So in other words, they want you to kind of look here. If you look, there is going across, this is your length, this is your width, and then this is your height. So what I always tell my students when they are trying to find all the different dimensions of a rectangular prism is pick a corner, and you can do a forward L and a backward L. And these are all 3 of your dimensions that you need to find. So also people pick to do, pick a corner and then do like a capital T going one way and then the other way. So, I mean, that is up to you guys how you want to do it. I just pick the forward L and the backward L as to picking a corner. So you could just do that. So if you look, how many are going across here? That is 1, 2, 3, 4, 5, 6. And then this one is 1, 2, 3, and 4. And then how high is it? Is 1, 2, 3, 4, 5, 6. This would be 6. So in this case, what are the dimensions of just the base of this box? That means that bottom shape. So what are the dimensions of the bottom shape? Well, remember each one is in centimeters. So therefore each one of these is in centimeters as well. So therefore the dimensions are a 6 centimeter by 4 centimeters. What operation can you use to find the area of that bottom shape? Well, when to find that bottom shape, you need to multiply those. All right, so here we go. You could use both ways. You could do that big B times H method, or you could just use, because we know that these are all going to be rectangular prisms this year, you could just use length times width times height. So what is the volume of each bead? Each bead, it already set up here, each bead is 1 centimeter. So therefore, if you look at just one block, this is a 1 by 1 by 1. So that means length times width times height of this would be 1 times 1 times 1, and they're all centimeters. So centimeters times centimeters times centimeters, remember that is centimeters to the 3rd power, and then 1 times 1 times 1 is 1. So therefore each bead is going to be 1 centimeter cubed. And then it says, what is the storage box has the base area of what? So they're just wanting that bottom shape. So if you're just figuring out that bottom shape, it is 6 centimeters by 4 centimeters. So they just want to know what this comes out to be. Well, centimeters times centimeters is centimeters to the 2nd power, which is also known as squared. So this is centimeters squared. And then 6 times 4 is 24. So therefore, just the base, the bottom area is 24 centimeters to the 2nd power, or centimeters squared, sorry. Then what is the height of the storage box? Well, we already talked about that. That is 6 centimeters. So therefore, the volume of this would be the base area. Again, we already talked about that, is going to be put right here, which is 24. centimeters to the second power times the height, which is 6 centimeters. So centimeters and then centimeters squared. And then another one would be centimeters cubed, which means to the third power. And then what is 24 times 6 is what we need to find out next. 24 times 6. Well, 6 times 4 is 24, carry your 2. And then 6 times 2 is 12, plus 2 is 14. So this would be 144 centimeters cubed. Next, use length, width, and height. You know that the area of the base of the storage box is 24 centimeters squared. So the base has a length of how many centimeters? So what is the length here? Well, we just wrote that here. The length is 6 centimeters. What is the width here? Well, the width goes back, and that is 4 centimeters. And then how high is this? Well, that is 6 centimeters. So in this case, you could do 6 times 4, length times width, because that is the base area, that big B, and then times 6. So what is 6 times 4? That is 24, then times 6. And then that will give us the exact same answer of 144 cubic centimeters. So these are both the same, because this one is just using the big B times H, and this one's using length times width times height. So it doesn't matter in this case, this year, which way you choose, because they will both get you the exact same answer. All right, it says, what if a cube-shaped bead measured 2 centimeters on each edge? How would the dimensions of the storage box change? All right, what if each cube-shaped bead now measured 2 centimeters instead of 1 centimeter now? Well, in this case, we would be looking at the same numbers here. So in this case, they're saying each cube, instead of it being 1 by 1 by 1, it is now going to be a 2 by 2 by 2. So that means each cube is going to be 2 by 2 by 2, length times width times height. That would be 2 times 2 is 4, then times 2 is 8 centimeters cubed. So each one is going to be 8 centimeters cubed now. Now, the other thing you could also think about is, so up here, remember how the length, the width, and the height were a 6 by 4 by 6. And now it's saying, instead of it being 1 for each, it is now going to be 2. So now it's not going to be 6. You would have to now times it by 2, and this by 2, and this by 2. So you would do 12 times 4 times 2 is 8, and then times 12. Well, if you ended up doing the math behind this, I will just save some time here. Your answer would come out to be 1,152 centimeters cubed to the third power, or you could have also said the cubic centimeters. So these were your 2 options that you could have wrote for that. All right, now we're going to come over here. It's saying the length of the rectangular prism is what? So remember, truly, it doesn't matter which one you want to pick, just as long as if you're picking the bottom shape, one of them has to be the length and one of them has to be the width. So it is up to you. These are kind of like interchangeable if it is a square at the bottom or a rectangle. So therefore, I'm just going to pick one. I'm going to say that the length is 5 inches because I want you to know that it is interchangeable. You do not have to go in that exact order. And then the other one is 4 inches. So what is the area of that bottom shape? Just the base. So 5 times 4 is 20. And then inches times inches is inches to the second power. So that is inches squared. Now they're saying, all right, now what is the height here? Well, the height is right here. So then remember, if this is your height, you guys can go ahead and know that since this is one side of that rectangle, the opposite side of the rectangle is also the same. So therefore, this is your 6 inches. So therefore, to find the answer to this entire prism, the volume of it, you would just take 20, because that was that bottom shape, and then times it by 6. So 20 times 6. 6 times 0 is 0. 6 times 2 is 12. So your answer is 120, and then your inches to the third power, or inches cubed. All right, next. It says the volume. What is the volume of this? Again, you could pick whatever one you would like. You could do big B times H, or you could also do length times width times height. This is truly the one that I choose to do a lot, but that is truly up to you which one you would like to do. So again, the length and the width are at that bottom shape. So it does not matter which one you choose as your length and as your width. So I'm going to change it up again, and I'm going to say that 3 is the length in this case, that bottom shape, and then 2 is the width. And then how high is it? Well, this is your height, so you got to just kind of follow that. This is the same as this side, so therefore your height is 3. So to do this, you would do 3 times 2 is 6 times 3. 6 times 3 is 18. So your answer is 18. And then remember, centimeters times centimeters times centimeters. That is centimeters to the third power, or also known as 18 cubic centimeters. All volume is in cubic units because there are 3 dimensions to it. All right, next one. Again, you could pick whatever you would like. I'm going to use length times width times height. Again, it does not matter what you choose as your length and your width. So I'm going to change it up. I'm going to say my length is 2 and my width is 6. And then how high is it? Well, this is the height. It is just 1. So I would do 6 times 2, which is 12. And then times 1 is 12. So therefore, this would be 12. But don't forget the units. It is inches times inches times inches, which is inches to the third power. Or you could have said 12 cubic inches. All right, so this one says, Rachel, Timothy, and Robin each make a rectangular prism shown. If they stand all their prisms together side by side to make one large rectangular prism, what is the width of their new prism, and how do the dimensions change? All right, so what they're saying is that this is one of theirs, and then this is the second person's. They're just going to have that exact same thing. It's just going to be standing up right next to it. And then here is the third person's, and it's going to be standing up right next to it as well. So in this case, we can see what changes here. So is the 8 millimeters going to change on these going back this way? And you should be saying, no, it does not. That is not going to be changing. But is it now just only 1 in length? And that should be a no. That now that one changes because you don't just have 1, you have 2, you have 3. So now this one is going to be changing to 3 millimeters. And then did the height change? Did we get any new height to this if they built the same thing? And this is where you should be saying, no, that the height does not change either because they're doing it side by side. So therefore, the height would still be 3. So in this case, the height and width didn't change. The length changed from 1 millimeter to 3 millimeters. All right, so to solve this, you would have to do, so then it says, what is the volume of this new prism? All right, so now we got to figure out what would be the new thing. Now remember, this one would be 3 by 8 by 3 is the height. So to do this, and you don't have to do it in that exact order. If you know that those 3 are there, remember this is all a rectangular prism. We're all timesing these numbers. So it does not matter which one you do first. You could have done 6 times 1 first. That would have been 6, and then times 2, and then that would have been 12 still. So do keep in mind that these numbers are kind of all interchangeable in the long run because they're all multiplication. So if you want, you could do it 8 by 3 by 3. And like I said, if you see something that is easier to multiply first, you should multiply that. So I see 3 times 3. That would be 9. Now times it by 8. That would be 72. So your answer would be 72. And then don't forget about your units. You're talking about millimeters. So millimeters times millimeters would be millimeters to the 3rd power, or cubic millimeters. All right, next, it says the rectangular prism is made of 1-inch cubes. If 2 more layers of cubes are placed on top of this rectangular prism, how many more cubes are added to the prism? What would be the volume of the new rectangular prism? All right, so they're saying if 2 more layers, so I'm going to say that there are now, we'll say that this is a layer that's being added, and then this is a layer that is being added. So first of all, if we have 2 more, how many, the question is saying how many more cubes would be added to this prism? That's the first question. And then the second question is, what would the volume of the new rectangular prism be? So this is your second question. All right, so in order to do this, what you need to do is you need to find out how much you're adding here if you add 2 more layers. Well, if I'm adding 2 layers, what I should do is figure out what 1 layer would be. So if you want to look here, how many is in 1 layer? Well, you got a 7 by 7. So 7 times 7 is just 1 layer, which 7 times 7 is 49. But that is per layer, and you're going to be adding 2 more layers. So you could have done 49 plus 49 or 49 times 2. 9 times 2 is 18, carry your 1. 2 times 4 is 8, plus 1 is 9. So actually you are adding, how many cubes are you adding? You are adding 98 cubes. So 98 more cubes. And then the next thing is, what would be the volume of this new rectangular prism? So this is still going to stay the same because the length and the width did not change. The only thing that changed was the height. So instead of it being 4 layers, you would have to add 2 more to that. So that is now going to be 6 layers high. So in order to do this, now you would just do 7 by 7 by 6. So 7 times 7 is 49 times 6 would give us that answer. So I'm going to do that over here. 49 times 6. 9 times 5 is 54, carry your 5. 6 times 4 is 24, plus 5 is 29. So therefore your answer would be 294. And this would be inches to the 3rd power, or 294 cubic inches. All right, next. The next thing, it says Richard is building a travel crate for his dog, Thomas, a Beagle mix, who is 30 inches long, 12 inches wide, and 24 inches tall. For Thomas to travel safely, his crate needs to be a rectangular prism that is about 12 inches greater than his length and width, and 6 inches greater than his height. What would the volume of the travel crate that Richard should build? So remember, it said the dog, was his measurements. It was, again, length times width times height. Now remember, his length was 30 inches long. His width was 12 inches wide, and his height, how tall he is 24 inches. Now, this was his measurements. Now it says that for Thomas to travel safely, actually shouldn't be timesing these just yet. This is just their measurements. It says that his crate needs to be a rectangular prism that is 12 inches greater than his length and width. So the length and the width need to be 12 inches bigger, in both directions. So with the length and the width, we have to add 12 inches to that to travel safely. So this would be a 2, this is 4. So this is 42 inches long is what the crate needs to be. And then times 12 plus 12, that is 24 inches, times then how tall, and 6 inches greater by his height. So his height, you're going to just add 6 more inches. That would be 30 inches. So then what they wanted you to do is, what would be the volume of this travel crate that Richard should build? So in order to do this, I would have to go and multiply 42 inches by 24 inches by 30 inches. And when you multiply all of this, just to save some time here, it comes out to be quite a large number. It comes out to be 30,240 cubic inches. All right, next. What happens to the volume of a rectangular prism if you double the height, and give an example? All right, so they're just saying what would happen if you double the height. So I'm going to say a volume would be length times width times height. So that would be 2 times 5. And then I'm going to say the height is just 1. That comes out to be 10 inches cubed. Now it's saying, what if you double the height? So I'm going to still have the same exact measurements here, 2 times 5. And then it said double that height. So instead of it being 1, it's now going to be doubled to 2. So this would still be 10. 10 times 2 is 20 inches cubed. So if you double the height, what ends up happening? Well, it went from 10 to 20. So the volume actually doubled because only one dimension changed. And that's what I want you to say. The volume doubled because only one dimension changed. All right, it says describe the difference between area and volume. All right, now area, remember area of a rectangle is length times width. And you're only multiplying two numbers. So therefore, your units are always going to be square units. However, when it comes to volume, this is your length times width times height. So now you are multiplying three numbers. And so now they are cubic units. All right, and then this one says, John used 1-inch cubes to make a rectangular prism shown. Write the value of the tiles that makes each statement correct. Each value can be used more than once or not at all. So please try this one on your own. So please pause it and try it on your own. All right, so you should have paused it. And if you did this, you should have said that 1 cube should be a volume of 1 cubic inch because it was a 1 by 1 by 1 would be just each cube. Then the layer of each prism would be a 7 by 5, which is 35 cubes. And then how many layers are there? There are 5. So 35 times 5 is 175. So that is how you do that. All right, now we're gonna get to your homework. So on your homework, you are going to have to write some things. So my advice to you is you could use one of these two. You could use the length times width times height method, or you could also use big B times H. Now remember, your big B in this case will be your length times your width because you're only going to have a square of a rectangle this year. Next year it's going to change, but this year this is what it is, length times width. All right, then also don't forget the units. I have to mark off if you forget the units. So it's very important you don't forget. So if it is cubic, you can say, if it's centimeters, you can say centimeters to the third power, which means cubic centimeters, or you can simply write out 90 cubic, and then whatever it is, in this case, it is centimeters. So do know you have to write both the correct number and this as well. All right, so make sure you are showing like what they are doing here. So in this case, show it, just say you would do 5 times 6 times 3 to get that number. And it is always good to do like 30 times 3, 30 times 3 is 90. That kind of stuff should be done. All right, so you have 2, 3, 4, and 5. You will not do 7, but we will do 6 together. Amanda's jewelry box is in the shape of a cube. What is that? Is 6-inch edge. What is the volume of this, of Amanda's jewelry box? All right, so it's telling you that it is a cube. Now remember, in a cube, all the sides are the same. So in this case, since it is a cube, it's telling you that the one length is 6. So if it is a cube, that means that the height and the width are also 6 as well. So in this case, you would do length times width times height. It would be 6 inches times 6 inches times 6 inches. So you could have said cubic inches at the end, or inches cubed, and then you would do 6 times 6 is 36, then times 6 more. So let's do that over here. What's 36 times 6? That would be 36, carry your 3. 6 times 3 is 18, plus 3, 18, 21. So that would be 216 cubic inches, or inches cubed. All right, next on the back, you were going to have all of them. So do all of them. Keep in mind on this one, it's saying what type of a triangle is shown. Remember, we've already talked about this. When you are naming these, make sure one of them is naming for the sides. The other one is naming for the angles. And then of course, your triangle. So do make sure you go back and look and see what type. It needs 2 names. Again, one is going to describe the sides. The other one is going to describe the angles. All right, and that is it for 11-8. I will talk to you guys later. Bye.